Good morning, ladies and gentlemen. Uh, Today we are going to be doing uh, word problem analysis or just word problems. Now, the objective of word problems is basically to formulate mathematical problems using normal English statements or any other language for that matter. But in our case, it will be English statements. And then we are going to use these English statements to analyze particular statements, solve problems using mathematical methods. So, while we're doing this section, the user given problem to design a mathematical equation using the statement that we will be given. And the method which is mostly used, but it's not necessarily the one you could use, but the method we'll be using is the buck system. Now, the buck system is basically the first step in developing the equation. You have to use the buck system so that you know what should be there, what shouldn't be there, what you need for the equation, what don't you need for the equation, and most importantly, the vocabulary of the equation. Now, the buck system is basically an abbreviation for B, meaning box the equation, box the question. When you say box the question, what we know is know what the question is in that particular statement. So there might be a lot of things that are written, probably a lot of question form sentences, but what is important is you should know what the question is in that particular statement. You will underline the information needed, meaning you should know which information is required in the statement. You may be given a lot of information, a lot of figures, but you find that some figures are to elaborate or to explain the statement given, whereas others are the ones you'll be using in a particular equation. So you should know what you need and what you don't need. And C, to me, is the most important part. You need to circle the vocabulary. You need to know whether or not these particular terms or statements, are you adding, are you subtracting, are you multiplying, are you dividing, or are you doing all? You need to know what adds, what subtracts, what is equated to what. Now, all these things, they are important because if you do not use any of them, so if you do not understand the vocabulary, you won't be able to note what is dividing from what is multiplying. And then this tool is also very important. You need to knock out the unneeded information. Like I said, you can be given a lot of information. Once you've taken out what you need, you also should note what you do not need. Because you may be given 32 figures in a particular statement, only to find that only 3 of them are important in designing the equation. The rest are not important. So you need to know what should be removed from the statement and will not be included in the equations. Now, like I said, C is one of the most important parts in a box system. Note the vocabulary. Note what is needed. Now, what do we mean? When we say note what is needed, what we mean is we have binary operators. We have binary operators. We have binary operators which are used to combine two or more elements. Now, a binary process, or should I say a binary operation, as given in the statement, is a process or calculation of combining two elements. And, or should I say, the items that are used to make these binary operations are called binary operators. That is, what we need to make a binary operation is a binary operator. And the binary operators that we know of are, of course, the four elements, which are plus, minus, times, and divide. These are the four basic binary operators. And remember, an operator takes two numbers and makes them into one. So let's take the first one, plus. The first binary operator, we need to know the vocabulary used in word problems so that you can apply it into a mathematical statement. Now, of course, the words below can be converted, of course, into a plus sign. Sum, plus, and, total, increase, more, raise, combined, in all, altogether, extra. There might be other types of words or other types of terms or synonyms to these words. For instance, is, for instance, with is one of the words which is not included here. As long as the word combines two things by adding one on top of the other, we say that that is addition. For instance, when you say that we are putting two parts together into a total, P1 plus P2, one may say in verbs, the total of P1 and P2 is T, meaning P1 plus P2 is T. Or another statement might say, the sum of P1 and P2 is T, same statement. There might be, of course, many other statements that are given. Or we raise P1 by P2 to get T, so on and so forth. There are many types of wording we could play around with to give the same equation. Now, let's go to the subtraction. We need to know the words that are likely to be used. They are present, past, and future forms if we're talking about verbs, or nouns and their synonyms if we're talking about words. So if we're talking about nouns. So the word that could be converted are more than, less than, decrease, difference, reduce, change, left, remain, dropped, lost, near, minus, subtract, take away, younger, older, and many other words. Older will apply with some. Older will apply with some, younger will apply with minus. For instance, the bigger and smaller amount as compared for a difference. Statement would be the difference between B and S is D. Or another statement might be, let's see, B is D more than S. If you take that S to the other side, it will be D plus S. So you can say B is D more than S. That's another statement. Whereas with sum, it will be P1 is P2 less than T. Sorry, P1 is the difference between T and P2. There are many words we could use, like I said. It's up to you how you convert it. Then we've got multiplication. Multiplication is times. And then the words can be converted to product of, multiplied by, factor of, double, triple, quadruple, each group, every, and so on and so forth. And the general formulation would be the group multiplied by the number in each group, and remember that each now appears again, to form that particular product. Or it could be the set or the whole thing multiplied by the number of times it may appear, or each group it appears, and which will give you the product. Like I said, the formulation or the mathematical structure is all up to you. What's important is giving out a correct structure. If I give it my way and you give it your way, you can convert your way to mine and I can convert mine to yours. That's the most important thing with mathematics. And then lastly, we've got division. And then with division, the word that can be used would be divide by, evenly, cut up, split, every, out of, shared, average, ratio, quotient, by fraction, and so on. So now you'll note that the word each appears, and the word every also appears with both multiplication and division. That's because the wording between these two, it determines whether you're multiplying or dividing. You have to actually thoroughly listen to the statement when you read it out loud. You have to listen to yourself whether is this, if I am dividing by, or it's the half of. They are both divided by 2. Now you have to listen to the statement, because at times 2 words may result in one thing, or 1 word may result in 2 things. So it's up to you to listen to the statement when you read it out loud. So we'll also note, of course, the difference in similarities between additions and subtractions, and of course multiplication and division, as we've also noted with the 2 words every and each. Now, let's take an example. The example given here is at a shop on Tada Street. 3 t-shirts sell every 10 minutes for 19.95 rand each. Every 45 minutes, one jet head sells for 24.95 rand. The shop is open from 9 a.m. until 9 p.m. every day. How many t-shirts are sold in a week? Now, the steps to follow here are given as follows. First of all, we always start with the box system. Box system will never let you down if you do it correctly. Box the question. That's the question. How many t-shirts? How many t-shirts are sold? Remember, that's the statement. How many t-shirts are sold in a week? Nothing else is required, just how many t-shirts are sold. Now, let's underline the information that were given relevant to the t-shirts. Remember, when you underline the information we require, it should be information relevant to the question given. First of all, we are told that t-shirts are sold every 10 minutes, so that 10 minutes becomes important because we are told the time the shop closes every day. And then the 3, and then the time it opens. Now, time is the most relevant part of this equation because time determines how many t-shirts are sold. Since we know how many in each time interval of 10 minutes are sold. So let's knock out information that's irrelevant. First of all, we don't want to know, we could care less about the price. So we knock out all the prices. We don't want to know about the 24 rand price because we are not asked to talk about jet heads. So anything that has to do with jet heads, the 45 minutes and the 24 rand 95 cents is irrelevant. The 19 rand 95 cents is also irrelevant because nothing has been said about prices and that price has no effect on the number that is sold. And then money or time not involving t-shirts. Remember, that's basically the word form of what I wrote above. If money is not relevant, time, if it does not revolve t-shirts, is also not relevant. So we do not need the information, and therefore we knock it out. Now, the shop opens between 9 a.m. to 9 p.m. That's 12 hours per day. Remember, it opens every day. So which means, because we're given in minutes, we convert hours to minutes. Because we want to know how many minutes are there in the 12 hours they open. And we find that they have 720 minutes per day. They open for 720 minutes. Meaning, in 10 minutes, they have sell 72 t-shirts per day. If every 10 minutes, so if they sell one t-shirt every 10 minutes, they have 720 minutes in every single day or in each day. And they sell 72 t-shirts every day. But of course, per week, they would sell 504. They'll sell 504 t-shirts. Now, we need to look at the statement again. Remember what the statement said. The statement said how many t-shirts are sold in a week. And what do we have here? We have t-shirts per day. So if we have t-shirts per day and they sell and they open every day, that means they open 7 days a week. And the question was requesting that we calculate the number of t-shirts sold per week. Therefore, we've got 504 t-shirts sold per week. Now, this is why it is important to have the back system so that you never forget the question at hand. We were not requested to calculate the shirts per day. We were requested to calculate the shirts per week. That's why it's important to have that back system. Of course, in this question, equations did not form part of our solution. It was just a simple calculation using one's logic. In some cases, on the other hand, you will be required to apply some formulation. Now, you've got this question. Andy is James' father. They are born on the 23rd of March. If you double, if you double, if you double current age, it is equivalent to Andy's age 8 years ago. How old are Andy and James currently if Andy is 29 years older? Now, let us analyze this question. The Buck system. What is the question? How old is Andy and James? So it means all the years that we are given, none of them are their age because we want to know both of their ages. So that's the question. How old are they? So what is the information that we have? Double James' current age. That's the information we have. And his age 8 years ago, we already have that. We have and his age 20. Andy is 29 years older. That's also very important. So the current ages references are crucial, as the statement said. So the current ages references are very crucial in the statement. So everything that we do is all around. We are comparing their age currently with their ages then and their ages years back. So everything that we do is based on the current age we are in. So let's circle some mathematical vocabulary. Double, order. Those are very, very important. And then you've got K. What are we knocking out? 3rd of March. That is irrelevant. We don't care about their birthdays. We don't care what the relationship of Andy is to James. So this information doesn't assist us. Now, let's go to the equation. First, since this question is not some simple question, what's important here is we need to introduce some variables. So let's let J be James and James' age, current age, and A be Andy's current age. So if you double James' age, it is equivalent to Andy's age 8 years ago. Let's do this one. Let's do the statement first. Now, the question says, what is Andy's current age? And the statement we're given here, which are very important, is if you double James' age, it is equivalent to Andy's age 8 years ago. Now, we already have J. Let's see. If let this be James' age or current age, and we let A be Andy's age. Now, the statement here says, if you double, now if you double, remember what double means? If you double James' age, and what is James' age? It's J. It is, remember we said is the same as equal. It is equivalent, or you can say is equivalent is also the same as equal. It is equivalent to Andy's age 8 years ago. When we say 8 years ago, remember, if you are 20 years now, if you're 20 years now, 8 years ago, you were how many years? 12 years ago, you were 12 years. And what is the difference? And how did you get the 12 years? You simply subtracted 8 years. So that's when you say 8 years ago, you simply subtract from the current 8. So we know that Andy is at least 8 years. So this is the first equation. Let us read the second one. Let's read the second one. So, like I said, when we analyze, we find the following results. Mathematically is, as I said, is written as equal. And double James' age, you got UJ. You subtract 8 years ago, we got negative 8, so I subtract 8. Then the equation is given as 2J minus 8. Andy is 29 years older than James. Let us analyze that statement. Andy is 29 years older than James. Andy is 29 years older than James. So at least we know Andy is the older one. Now, again, let's go back to the slide. So, of course, then we have this. And then now these are two equations with two variables in the form. And then we simplify the solution. Now, of course, in our case, if you take B, because these are two variables, remember what we said, you take all your unknowns, put them on one side, all your knowns on the other side, and then you've got 2J minus A equal to negative 8. And then you've got minus j plus a equal to 29. And then if you solve by elimination, you will find j is equal to 21. J is currently 21 years old. And then we know Andy is 29 years older, meaning 29 plus 21, which is 50. So you convert, you always, I repeat, you always convert your words to, your equations back to words. Remember, the question did not ask you about A and J. The question asked you about Andy's age and James' age, not A and J or whatever variable you decide to use. So after you're done with your calculations, you always convert from maths back to words. Word in, word out. We will. Word in, word out. We will. Now, of course, I'm going to apply a different formula. Here we used the elimination. I'm going to use the substitution. So we've got equation 1, we've got equation 2, but automatically this is already the subject. So there's no need to create equation 3. So I say Tj is equal to A minus 8. But what is A? A is given as 29 plus J minus 8. And then I take J, this side I've got 2J minus J, which is equal to 29 minus 8. And what is 29? 29 minus 8 is equal to 21 on the side. 2J minus J is equal to 1J or J. And then I found equation 1. And then A is equal to 29 plus J. And therefore we've got 29 plus 21, which is 50. And then, of course, you convert it back to words. Now, go to the second one. A customer buys 5 rands apple and 6 pears at a fruit stall and is charged 3 rand 50. Another customer buys 2 apples and 5 pears and is charged 2 rand 15 cents. How much each are the apples and pears? Now, as I said, you use the box system. Box system is given as follows. B. The question is, how much are each of the apples and pears? So both the price of the apples and the price of the pears are required. Remember the prices. So meaning money is very important, but money relevant to apples and pears because they do things in pairs in the statement. Now, the underlined important information here is 5 pears were bought along with 5 apples along with 6 pears were bought. And the sum of those 5 and 6 was 350. 2 apples and 5 pears were bought, and their total fee charged is 2 rand 15 cents. Another information which is very important, which is also part of the question, is how much. The question doesn't ask how many, it asks how much, meaning it requires money. Now, another crucial information in the statement is. That is C, the vocabulary. C is an important word because is the one that forms the equality sign. Then each determines whether you're multiplying or dividing. Now, And then you've got K. Customer, we don't care whether the person was the customer or a family. That's irrelevant to the statement because it wasn't said that they were given family discounts if they were customers. So whether they are customer or not is irrelevant to the statement. Where they bought the fruit is also irrelevant to the statement. Now, as always, you always start with what are you given? Okay, what are you expecting to calculate? Apples and pears. So let me find a variable for apples and a variable for pears so that I can better analyze the mathematics. So we have A, which is the price of apples, because we remember the question said how much, and then the price of pears. And the statement is the first statement that we're given is 5 apples and 6 pears, blah blah, is 3 rand 50. Mathematically, this is 5 pears, apples, sorry, and the price of apples is A, and goes with, if you remember the vocabulary that we did, and goes with plus 6 pairs and P pairs goes with P is the equality sign, and 350 is that. And the second statement said 2 pairs and 5 pairs, so 2 apples and 5 pairs, blah blah blah, is 2 rand 50 cents. And we've got 2 apples is A, and it's plus. We've got P, which is pairs, 5 pairs, and then is equal to, and then 2 rand 15 cents. And then we've got, since we're solving for A and P simultaneously, these are your equations. You convert 3,5 to 7 over 2. You convert 2,15 to 43 over 20. Remember, we said we're trying to avoid, by all means, to have any decimal or any fraction. And then the first equation, of course, we multiply throughout by 2 to avoid any fraction. And then we've got 10a plus 12p is equal to 7. That's for the first equation. The second equation, we multiply throughout by 20 everywhere, such that we've got 40a plus 100p is equal to 43. And then, for simplicity, I will use the elimination, but of course substitution also works. I will use elimination, add it with the second equation, and then the first equation is negative 40a minus 48p equal to negative 28. That's our first equation after multiplying by negative 4. And then I've got 40a plus 100p is equal to 43. And then the total is 52p, which is equal to 15. And p is 15 over 52, which can also be converted to 29 cents. Remember, money is always in 2 decimals. Then I can put that amount. I will choose to put the original fraction, because try by all means never to use an estimated value. The moment you convert it to a decimal and round it off, it's no longer the actual value, it's an estimated value. Always use the actual value. And then you've got 10a is equal to this, which means a, after you've divided by 10, remember the way we did solve for x, it's 23 over 65, which is 35 cents. And then after you've done all that, you convert your answer into, you convert your mathematics into a word answer or a word solution, which you will state in words. Therefore, apples are 35 cents, or you can say 0.35 rands if you prefer, and 29 cents or 0.29, because we said our values are put in rands. Ladies and gentlemen, thank you very much. This has been a wonderful lecture.